In this video, I want to show that this series converges by the ratio test, and then I want to show that it converges to 2 times the natural log of 2 minus 1. So here, let a sub n be the expression 1 over 2 to the n times n plus 1. And then a sub n plus 1, in the place of n, we just have n plus, we replace n with n plus 1. The ratio of a sub n plus 1 and a sub n would be this expression dividing by this expression. And then simplify, we get 2 to the n times n plus 1 dividing by 2 to the n plus 1 times n plus 2. And then 2 to the n dividing by 2 to the n plus 1 is 1/2. And then here we get n plus 1 dividing by n plus 2. So the limit of the ratio of a sub n plus 1 and a sub n is n approaches infinity, be the limit of this expression right here. And then this is the constant 1/2, so we can move it and place it in front of the limit. And then for the expression n plus 1 over dividing by n plus 2, what we can do is divide everything by n. So n dividing by n is 1, and then 1 over n, and then n dividing by n is 1, and then 2 over n. And then as n approaches infinity, this part 1 over n approaches 0, 2 over n approaches 0, and so we get 1 for this expression here. So 1/2 times 1 is just 1/2, and 1/2 is less than 1, and therefore the series 1 over with the expression 1 over 2 to the n times n plus 1 converges by the ratio test. And recorded, the ratio test says that if the limit of the ratio a sub n plus 1 over a sub n if is less than 1, then the series converges. And now let's show that the series with the expression 1 over 2 to the n times n plus 1, that show that this series converges to 2 times the natural log of 2 minus 1. Recall that the power series representation for the function 1 over 1 minus x is the summation with the expression x to the n. Where x is between negative 1 and 1, this series right here converges for x between negative 1 and 1. And so we have 1 over 1 minus x is equal to 1 plus x squared plus x to the third, and so on, for x between negative 1 and 1. And now what I'm going to do next is I want to integrate both sides from 0 to 1/2. And so the reason for the 1/2, because I have 1 over 2 here, so that's why I'm using 1/2, 1 over 2. For this integral, we can use the substitution method, so let u be 1 minus x. So du over dx is negative 1, so dx is negative 1 du. And then this becomes 1 over u, and then dx is negative 1 du. And recall that the integral for 1 over u is ln of u, and then we have a negative right here. And then evaluate from, and then u is 1 minus x, and then evaluate from 0 to 1/2. So when x is 1/2, we get 1 minus 1/2, which is 1/2. When x is 0, we get 1 minus 0, which is 1, and the natural log of 1 is 0. So we end up with negative natural log of 1/2. And then we can rewrite this. This is the negative here. We can rewrite this as natural log of 1/2 to the negative 1. And then 1/2 to the negative 1 is 2. So the left side we get the natural log of 2. And then for this part, we just get the x, and then x squared over 2, and x to the third over 3, and so on. And then we can rewrite this as the summation with the expression x to the n plus 1 over n plus 1. And then n starts at 0. And then evaluate from 0 to 1/2. So when x is a half, we get a half, and then when x is 0, we just get 0. So this will be the right side. So the left side is L natural log of 2, and then the right side is this expression right here. And then the series that we after is this one, and it starts at and n starts at 1. So what we can do is go ahead and go ahead and write the first term out, and then n, the rest of it will have n starts at 1. So when n is 0, we get 1/2 up here, and then we get 1 down here, so we get 1/2. And then the rest of it is this. And then this can be rewritten as this part here is the summation with the expression 1 over 2n to the n plus 1 times n plus 1. And then let's go ahead and subtract 1/2 from both sides. And then now we can see that this series right here looks almost like this. The only difference is that plus 1 right here. So what we can do is multiply everything by 2 to get rid of this 1 right here. So multiplied by 2, we get 2 times the natural log of 2. And multiplied by 2, we get negative 1. And then here we're multiplying by 2. And then this be 2 times 1. And then 2 dividing by 2 to the n plus 1 be just 2 to the n down here. And then now we can see that this series, it looks exactly like this. And therefore the infinite series with the expression 1 over 2 to the n times n plus 1 is equal to 2 times the natural log of 2 minus 1, which is approximately 0.3862. And so in summary, we have shown that this series converges by the ratio test, and then we have shown that it converges to 2 times the natural log of 2 minus 1. And that's the end of the video.